Hello, everybody. Today is just going to be about data science. Last week we covered loop algorithms. Right? We really just used a bunch of for loops to go through some data sets. And in particular, a large data set that we've seen is Major League Baseball players. Uh, this was the assignment project that was assigned last week. This week, we're going to see another version of this. Another version, it's going to be the same exact assignment. Right? So same exact Major League Baseball, but we're going to use a library called Pandas. Right? There is a Python library that will allow us to do looping algorithms in a much cleaner fashion. So, before moving on, if folks are on this recording, make sure to understand the previous project first. That the previous project relied on writing for loops to go through large data sets. Today, we're going to be doing the same exact thing, but with a library instead. All right. I'm going to do things a little out of order today. Typically, we start off with the lesson and then jump into the lab. I'm going to do the reverse. I'm pretty much going to do a sneak peek first, right? Like a very small playground sneak peek into today's material. And then we'll move on to the lab. Right, we'll do this lab together and then move on to the lesson. Right, so a little out of order. Just we're going to do a sneak peek. We're going to do the lab next and then the lesson. Right, the reason why is because it's kind of building up in difficulty. Right, the sneak peek will be really small. The lab will be getting a little bigger, right? And then finally the lesson is the biggest. The lesson will give us the best hints for the next project, right, which is already published. Okay, so here let's give folks a sneak peek real quick. So we're going to have a couple things open. Let's see, it's going to be the lesson on data science. So lesson number 18. And then also the lab 18. So let me bring up both of them. Okay, cool. I just loaded up both of them. Let me navigate back to my lessons. Okay, so I got both of them open. Right, I'm gonna make another playground cell in just a bit. Playground notebook, I mean. Just a quick sneak peek into data science. Right, last week we did some looping algorithms. That is the start of data science. Right, you can think of data science as like the foundation for a lot of artificial intelligence or machine learning. Right, data science is kind of like the study of data. Right, like you're parsing through data and kind of learning from it. So let's do that today. In particular, we're going to be using something called Pandas. Right? Pandas is a Python library. It's short for panel data. It basically makes it a lot easier and cleaner for looping algorithms. Right, so once again, the prereq for today is kind of knowing how to do the looping algorithms from last week. In particular, make sure that you've done this previous project, right? Major League Baseball players, right? Once you've done this assignment, today's material will be pretty cool, actually. Okay, so here, let's jump into it. We're gonna see a couple terminology in the sneak peek. In particular, I'm gonna be saying data frame a lot. Right? Data frame is a way of representing panel data. I'm also gonna use this terminology again, series. Right? Series is like a piece of the data frame, right? So like here in this data frame, there are a bunch of series, right? Each column is a series. Each row is also a series. So yeah, those are the two main terminology I'm going to use a bunch. So here, I'm going to navigate away from this lessons and make a sneak peek notebook. So let me go into my playground here, sneak peeks. I'm going to create a brand new notebook to give folks a little start. Okay, let me rename this. I'll name it Pandas Sneak Peek. The goal of this notebook is to get a very small introduction to this library. Okay. Let's see. Okay, imagine we're going to parse a data set. Right? Last week, you might have seen this data set last week in another playground notebook. Now, you might have seen this data set here, right? It's like a list of dictionaries that contains name, age, and height. It's possible to load data into something called a data frame. Right, so here, let me represent this same dictionary in a different format. Right, so imagine if we have some data here. Right, so I'm going to say data is equal to some dictionary. Okay, I'm going to represent that data in a different format because the library we're going to use will kind of rely on this format. Basically, I'm going to represent a dictionary where each key represents a column name, right? Like let's say we have a column name name, right? And then I'm going to say the value contains a list of names. So let's say Andrew, let's say Bob, and let's just say Bob happens again. Right? It's possible to have two Bobs in the same list. All right, Charlie, then David. 1, 2, 3, 4, 5. Let me do 6 of them. George. Okay, I'm gonna do George as his last one. So, anyways, I'm attempting to represent data, right, where the columns are the key, right? So the column name is in the key, and the actual data is in here. Right, so let me make another column. Right, so imagine that there's another column called like a birth year. And in each column, I'm just gonna put some numbers here. Like let's say Andrew birth year is 1996, and let's say Bob's birth year is 1972, and let's say the other Bob's birth year is let's see 1980, and let's say Charlie's birth year is 2004, and then let's say David's birth year is 2009, and then finally we'll say George's birth year is like 2007. Here, actually, let me change the numbers around. Let me make Charlie 2009. I'm just going to change the numbers. All right. Okay, it doesn't really matter too much. So imagine like an Excel spreadsheet, right? The Excel spreadsheet, we have two columns, right? Name and birth year, right? In each column underneath, we're going to have the values associated with it. So with this organization, right, this is a dictionary, right? It's possible to load this dictionary into something called a data frame. And so once again, a data frame, we'll see this in a bit. Right? A data frame is a pandas terminology that represents data. So let me load this dictionary into a pandas data frame. So we're gonna have to import something. So I'm gonna import something called pandas at the top cell. Here, let me insert a cell above. Now we got to import something called pandas. And once again, this is short for panel data. I'm going to import pandas, and then go ahead and load it into something called a data frame. So there is a function in pandas. It's called read. No, it's not called read. I think it's just data frame. Pandas.dataframe. Pretty much, I'm going to convert this dictionary into data frame. Okay, so this is putting the data in here, and this should return a data frame. Right, so here, let me test it. Okay, cool. So once again, a Jupyter Notebook here is just showing the result of the last run statement. Right, it's just showing this result. Right, this is just a data frame. Typically, we would store this into some variable so we can work on it later. So I'm going to store this in something called df. Right, df is short for data frame. So there it goes. I'm just going to run it. Right, there's no output here, but if we make the last statement df, right, Jupyter Notebook will show this result here. So it's just showing df. Right, and once again, you can print it as well, but it won't be as formatted. Right, if I print the df here, right, it's the same thing. It's just a little less formatted. I'm just going to rely on the Jupyter Notebook's representation. Right, so I'm just going to get rid of this print statement. Okay, here's a data frame. Right, a data frame, here we see the dictionary got translated. Right, so right now we just hard-coded some values, but in the future we're going to download larger data sets and load it in. We'll just keep it small for now. All right, hopefully people are cool with this so far. Okay, so we just created a data frame, right? Let me comment this. We created a data frame. Creates a data frame from a dictionary. Okay, so that's all we did so far. So let's do some cool stuff. Right, last week we learned about a bunch of algorithms, right? Like let's see. Let me go back to last week real quick. Okay, so last week we did some reduction algorithms, right, which takes a bunch of sequences. It takes a sequence and puts it down to one. Right, we did some filtering algorithms, right, which grabs a subset of certain values, and we also did mapping. Right, so let's kind of apply some of this to the data frame. Okay, but before I do that, let's just navigate this data frame real quick. All right, let's learn how to navigate this. So this data frame is called df, right? That's how we stored it. So I'm gonna start simple, right? df, right? The Jupyter Notebook will just show this result. The cool thing about these data frames, you can think of it as like you can think of it as a data structure of dictionaries, meaning that we can index certain pieces. Like if I were to index the name, right? So if I were to put the name here in square brackets, right, it's going to give us something called a series. Right? So a series is a piece of the data frame, right? As a visualization, right, this is the data frame, and then here's a series, right? Just a piece of it. So what we did here was we selected a series, right? So this is selecting a series from a data frame. Okay. A series are pretty fancy, right? You can think of a series as a dictionary. Now we'll talk about this in just a bit, but we can select another series, right? Like there is another column called birth year. So we could say df. This is in another cell, by the way. I'm going to create a bunch of cells just so I can take advantage of Jupyter Notebook showing the result of the last run statement. Right, once again, you can print it. Okay, so once again, this is doing the same thing, right? This is selects a series from a data frame. Oh, where did I call pandas in? At the very top cell, just did like an import pandas. Yeah, that's pretty much today, just learning pandas. Yep, exactly, import pandas. Okay, so yeah, once again, you can print it, right? It's the same thing, but it's a little less formatted. And basically, the reason why I'm not printing it is because I'm going to do a bunch of single cells only. Right, well, just to reiterate, our Jupyter Notebook shows the result of the last run statement. So if I print like a hello here, right, it's not going to show the birth year. So yeah, it's because this first line is selecting something, right, and this next one is printing. And in Jupyter Notebook only shows the result of this last run. Right, but if I were to actually print both of them explicitly, then it's actually going to print the selection first, right? it's going to print the selection and then print hello. Right, so once again, I'm just going to stick with small cells. Okay, so we just learned about selection. Right, here's the cool part. You can think of this as like a dictionary or a hybrid list dictionary. Right? This is not really a single value, right? It's like a sequence of values. What if we were to access, one value at a time, right? Like what if I wanted to access this very first element, right? Folks might be guessing that you would do like a 0 here, right? Meaning grab the first value from this series. Now, this is not necessarily going to work. Oh, it does work. Okay, cool. It does work. So yeah, um, the reason why I said it might not necessarily work is because Pandas uses a different type of syntax, where they have an attribute called index location. Now, we'll talk about this later, but it's the same thing, right? I'm going to keep it as plain for now. I'm not going to use iLock yet. So once again, this is like saying grab the 0th value from this sequence. And yeah, 1996, go 5. Right. So yeah, once again, this is selecting a value from a series. Right, selecting a value from a series, and we're selecting it based off the index. Okay. Let's take this a step further. Let's do some mapping. Right, like here, let's motivate why we might need to do a mapping algorithm. Right, so once again, mapping algorithms are taking a sequence and putting it to another sequence. If I were to access something called age, right, let's see what happens. So this new cell is saying, hey, select the column named age. Right? But it's going to give me a key error. Right? It's saying key error, age. Basically, this column doesn't exist. Right? Like here, let me just make another cell. Sorry for all the cells. I'm just going to do a bunch of cells so I can help visualize what the DF currently looks like. Okay, so data frame looks like this right here. Right? There's no key named age. So I hope that makes sense why this is giving us key error. It is possible to make this exist. Right? It's kind of like dictionaries, right? How do you make a dictionary value exist? Well, one way is you can just use the equals, right? If we put equals here, this is saying, hey, create a new column and set it equal to something. Right? In this case, here, let's take it slow. I'm going to set it equal to the same thing, right? Birth year. Okay. So this is saying create a new column named age, right? And then set it equal to the birth year. But it's the data frame now has a new column. Right? You see this age right here? Right? So all we did was we created a new column. If anything, we just need to modify this number. Right? This number is the current year minus the birth year. Right? So I'm just going to hard code a 2025 for now. Right? So now this is going to do something different. Right? The right side, it's pretty cool. It's pretty cool what's happening here. Right? We're taking a number and we're subtracting a series from it. Right? So this is going to give us another series. Right? The right side will become another series, and it's going to get assigned to this left part. So let's run it. So I'm going to run this and show the visualization again. Pretty sweet, right? So this is a mapping algorithm. Right? We mapped the birth year column into another column named age. So here, let me comment this real quick. So this is maps the birth year column into a new one, new age column. Right. So yeah, there's kind of two things happening in this. Right? On the right side, it's calculating a series, right? Like if I were to comment out this part right here, right? This is technically a series, and it looks like this right here, right? This is pretty much saying take the number and subtract every single value from birth year, right? Well, once again, birth year looks like this, right? Birth year is a series of numbers, and if we subtract 2025 from it, right, it gives us another series. Right? So we're taking this whole series and assigning it to a new one called age. Right, so that's kind of what's happening there. Are people cool with this so far? All right. So we just did a mapping algorithm. So once again, mapping algorithms are like this right here, right? This is the previous lesson. And we mapped a sequence to another one. Right? We went birth year to age. Okay, let's go back here. Let's do some filtering, right? Like, what if we were only interested in selecting people above 21, right? Like, this is a whole data frame, but we can filter it, right? So here's the cool part about filtering. It's kind of like selection, but there's going to be some weird syntax to it. So here, I'm going to create something. I'm not create. I'm going to select age, right? Once again, this is going to give us a series of numbers, right? It's a piece of the data frame. But what if we only cared about people above or equal to 21? So we can take this series and perform a Boolean operation on it. This is going to be some pretty cool stuff, right? We can just say, hey, this is greater than or equal to 21. Right, so this is saying, grab a series, right, and then compare it to this number. So there's going to be some magic happening. Right? It's going to compare every single number to 21 and give us a list of Booleans. So here, let me play this. Okay, there we go. I just pressed play and kind of see what happened. Right? The result of this Boolean operation is a series of Booleans. Now, once again, I keep saying series, but if I look at the type here, right, the type is a series. Right? But basically, a series is like, it's kind of like a row or a column. Right? In this case, it's like a column. All right, so we just created a series of Booleans. It is possible to use this series and filter this whole data frame out. So this is the part where the syntax might look weird. Basically, we need to use this as a condition, right? And use that condition to select. Right? Once again, when we select items, it's going to be with square brackets. So I'm going to put another df here. Another df. So yeah, this is going to look weird. Right? But basically, this is, you can kind of like treat this inner part as a criteria. Right? So we're selecting from the data frame, but our criteria is that the age must be greater than 21. Right? So this is going to give us a filtered data frame. Right? It's let's see. So let me comment this. This is selecting. This is selecting from the data frame using a criteria. Right? And in this case, the criteria is a series of Booleans. Okay, so yeah, once again, selecting, right? This is the selection part, right? Like here, oh, what do we want to select, right? I mean, you could select name, right? And it's just going to give us the series, right? But we're taking it a step further, right? We're saying select from this criteria, right? And then it's going to give us a filtered data frame. There's less people in here. And so this is selection. We're kind of filtering it. It might be a good practice to kind of assign this to another variable, right? Like what if we wanted to store another data frame but have the filtered elements, right? So in this case, I would create another variable, right? I'll just call it like, let me see. I'm just going to call it data frame over 21. Right? This is saying, hey, select from that data frame, right, and then set it equal to this variable. Right? One reason is you might want to use this variable later. Right? In this case, this is just another data frame. Okay, so there it is. I just selected from there. It's not showing anything because all we're doing is assigning. So I'm going to take advantage of the Jupyter Notebook showing the last run statement by putting df over 21. Okay. All right, so we just did two things. Right? We did a mapping algorithm. Right? The mapping algorithm converts this birth year into an age column. Right? And then next, we did a filter selection and created a brand new data frame. Right? We have a brand new data frame called df over 21. Okay, let's do some more. Let's see. Let's do some more selection. Right? Like, what if I wanted to select all of the Bobs? Right? So our filtered data frame is df over 21. Right? What if we wanted to select people only named Bob? Right? Well, we need to create some sort of criteria where the name is equal to Bob. And so let's create this criteria. Basically, the criteria is we're going to use this name column. Right? We're going to use this name column, but we want it to be equal to Bob. Right? So I'm going to put a double equals Bob here. Right? This is comparing a series to a single string. In this case, it's going to give us another series. So here, let me run this. You kind of see what happened here, right? This next series represents where this Boolean is true, right? So the Boolean is true on here and here, right? Which makes sense because we have Bob here and Bob here. It is possible to use this criteria to filter the data frame. Right? So here, let me filter it. Right? So this is our criteria. I'm going to use this to select it from the original. It's called df over 21. Right, so we're selecting from this data frame. I'm going to use another set of square brackets. And there we go. Right, we filtered it even further. Right? Or it's not really filtering, it's selecting. Right, so this is still selecting another data frame. Selecting based off a criteria. Right, in this case, the criteria is the name must equal Bob. Okay. Sometimes it might be necessary to grab a single element. Right, like this is technically a data frame, and sometimes it might be necessary to grab that first person here. Right? One way we can grab the first person, right? We can't really use a 0 here, right? Like here, let me try to grab the first person using a 0. Right? So this is not necessarily going to work, right? Because so once again, we're attempting to grab this part right here, but it's a data frame. Right? This is a whole data frame, right? And you can verify that with the type function. But with a data frame, if we want to select the first thing, there is a function or an attribute. It's called index location, right? So I lock for index location, and I can say I lock 0. So this is saying index location of the first element. So this is going to give us Bob right here. Right, this is first row. Right, that's all it's printing. Okay. So this is a series, right? Just to verify it, if I put it in a type function, right, it's a series. It's a piece of the data frame. So, it's possible to index things from this series, right? Think of a series as kind of like a fancy list slash dictionary, right? So this is going to look weird, but if we could grab the value at the birth year, right? Like you can think of these as key value pairs. Right? We have a key name, a value named Bob, another key named birth year, right? Another value here. Right? So think of this as a dictionary. Right? When we index in dictionaries, we can just use the key in these square brackets. Right? So I want to put the birth year here. Right? This is saying grab this whole quote unquote dictionary and grab the value that's associated with this key. Right? So this prints 1972. This is the person over here. Right? And once again, we can grab the next person with index 1. Right? If we use the index 1, it's going to grab the next person. And that would be 1980 here. Okay, hopefully, once again, this is a sneak peek. It's going to make more sense in just a bit. I'm kind of throwing a lot of terminology here. Right? In particular, I'm using data frame and series a bunch. So this will make more sense in a bit. I'm going to jump into the lab in just a bit. All right. So let's see. This is selecting a value from a series, from a single row, which is a series. All right, so here, just kind of taking this apart real quick. Right, this first part that I highlighted, this is giving us a data frame. All right, so here, let me build up to it. So this first part gives us a data frame, right? And we want to grab a single series from it. Right, so the way we grabbed it was by saying .iloc, right, for index location, and 0. And so this is now a series. Right? So a series is like a fancy dictionary, and then we grabbed a single value by indexing some birth year. Right? There's a lot happening in this line, but I hope that kind of makes sense what's happening. We read it left to right. All right. Let's do some more on this, and we'll move on to the lab. Let's talk about reduction algorithms. Reduction algorithms, we seen this last week. Right? They pretty much take a sequence and collapses it down to a single one. In our previous assignment, the Major League Baseball players, right? We've done some, statistics. Right? Statistics are like reduction algorithms. So if you did the previous project, then you might be familiar with the mean, the min, and the max. Now, those are reduction algorithms. So let's apply the same to here. This is going to be pretty cool stuff, actually. So last week we did some, for loops to calculate this, right? Like when we reduce, typically you write a loop to go through each value and then kind of do some math, right? And then that math would give us a single value, right? The cool thing with Pandas, this library, it'll do the math for us. So here, let's work with our original data frame, right? We do have this df here. And this is our original large data frame, right? Not the filtered one. Let's say we were to calculate the average age. So here's the cool part, right? You might think that we'd have to do some sort of statistics, looping algorithms, right? In particular, we are going to be working with the age column, right? So here, let me just select the age column, right? So how do we calculate the average of this? Right? One way is to loop through all of these values, right? Add them all up, and then divide it by the length. Right? You could totally do that, which was the previous assignment. But Pandas data frame has a cool function, right? There's a function called, I think, average. Right? But basically, it's a data frame dot average. Oh, okay, it's not average. It's a mean. My bad. Mean is a synonym for average. So you kind of see what happened here. Here, let me make another cell. So our original data frame was here, right? So df, that's our original. And then when we selected the age, right, this gives us a series, right? And series have functions attached to them, right? Like, for example, mean. And this is the average of all the ages. Right, see, we don't have to do any for loops, right? This function is already doing it for us. All right. Okay. So this is a reduction algorithm. Right, another type of reduction algorithm you might see is finding the min and max. Like if we were to find the minimum age, right, it would be the same thing, right? We would grab the series, right? So here I'm selecting a series from the data frame, right? And then I'm going to do a dot min. Right? Dot min is a series function, right? It's going to give us 16. Right? This is reducing the whole series into a single number, right? 16. And then finally we can get the max as well. So let me get the max. Right, max is just max here. And yeah, it's 53, right? Which makes sense because that's this person here, right? This Bob. It might be useful to print the name associated with this max. Like what if we wanted to print out Bob? Right? This is the number that represents Bob, but it's not really printing the name. So there's a couple ways on doing this. Right? One way we could do it is use this number as a selection criteria. So remember, we could filter data frames based off of some Boolean, right? Like let's say we wanted to filter this age here, right? Well, one way we could filter is by creating a criteria, right? This criteria, I'm going to represent it with this Boolean. I'm going to say, hey, where is this age equal to the max, right here? So I probably need to create a variable to store this number, right? I mean, you could do it like this, but this is going to be a little harder to read. Right? It'll probably be more easier to read if we store this number into a variable. I'm going to call it like max age, or I'll just call it oldest age. Right, oldest age. And then let me just print it. Okay, there we go. I created a variable called oldest age, which just stores 53. Right, we could use that number to create a selection. So I'm going to put oldest age here. Right, so let's see what it does. Right, this is taking a series and is comparing it to a single number. Right, the cool thing is it's going to give us another series of where this is true. So let me run this. And yeah, you kind of see what's happening here. Right? We wrote a criteria. It gave us another series that showed us where it's true. Right? In this case, this criteria is only true on this element. Right? Which makes sense because that's this person right here. Right? So this is going to look weird. Right? We can use this criteria to select. Right? So I'm going to put df here. Right? It's going to look weird, right? But basically this is saying use this criteria to select from this data frame. And it's going to give us another data frame. All right, once again, this is a whole data frame. Right, you can verify it with the type. All right, see, it is a data frame. Okay, so yeah, once again, we're just selecting. Right, like you could select it by saying, hey, who is younger than the oldest age? Right, so if we said who is younger than the oldest age, it's going to give us everyone but that first Bob. right? Just to kind of take it back a bit, right? Like this is, I'm going to delete some stuff here. Right? So this is our selection criteria, right? Who is younger than the oldest age? Right? It looks like everyone, right? Everyone except this person, right? This person, once again, is Bob right here. All right, so yeah, this makes sense. So if we use this criteria to select from the data frame, right, it's going to produce a data frame of where it's true. Right? In this case, all of these people are true, and it ignored that first Bob who was 53. Okay, but here, let me set this back to an equals equals, because our original goal was to print the name of the oldest person. And so one way is we could select it based off of the oldest age, right? And then this is a data frame, right? Meaning that we should index one of the rows here. Right? So one way we can index the row, right? We've seen this earlier. It's a index location. Right? So we can use an iLock here. It stands for index location, and I'm going to put in a 0 here. Right? This is saying grab the row, grab row 0 from this data frame. Right? This is going to give us a series. Right? Once again, you can verify this with a type. Right? A type. This is a series, right? And you can think of a series as a fancy dictionary, right? Meaning we can index the name value here. Right? So yeah, this is going to look tricky, right? But see, it prints Bob. Right? So this is the series, which is a fancy dictionary, and we're indexing the name based off of there. All right, so yeah, this is, I'm going to store this in a string, right? This whole thing is a single value string. Right? So it might be useful to store this in something called like oldest person. Right? And then see, it'll store the oldest person, meaning that we can print it out. And there we go, prints Bob. Right, so let me just comment this real quick. It says selecting the name of the oldest person. Okay, if folks are having trouble kind of following along with this, you can, I would suggest taking it slow, right? Like build up to it slowly, right? Like once again, we started off, right? We started off by selecting the whole age column. Right? This is the whole age column, and then we created a criteria, right? In this case, we said the criteria is where are the ages equal to the oldest age. My criteria is only true over here, right? So we're using this criteria to select. And once again, the select is with the square brackets again. And we use a selection, there we go, selected, which produces another data frame, right? And then finally we grabbed a single row, right? Because this data frame could have multiple, it could have multiple rows, right? Like what if multiple people are 53, right? So I'm gonna just grab the first row here, right? iLog 0. This is the index location. It gives us a series. And we can use this series like a fancy dictionary. Right? In this case, I'm just gonna grab the Bob here, which is indexed by his name. Right, so that's kind of what's happening. Right? This might look like a lot to read, but just see if you can kind of build up to it slowly. All right. So that was pretty much the sneak peek of today. All we really did was hard code a data set. Right? We hard coded a small data set. We added to it an age. Right? See, this is our original data frame that we grabbed from the data set. We ended up mapping the birth year to a age column right down here. This is saying create an age column and set it equal to this series. Right, so there we go. We created an age column. And then next we just did some selection. So yeah, that's our sneak peek here. Okay, I know this was a lot and pretty dense. It's going to make sense in just a bit. right? We're going to move on to the lab and then the lesson. Right? It might seem like a little out of order, but it's kind of in increasing order of difficulty. Right? The lab is next, right? Next in order of difficulty, and then finally the lesson here, right? We'll do the lesson last. Right? The biggest reason is because it's kind of dense and it gives a lot of hints for the next assignment. This lesson is pretty much how to do the next assignment. So here, let's jump into the lab. Once again, we're doing data science. Right? We're taking data and kind of learning statistics from it. Let's do this lab together. Right? In particular, we're going to work with another data set. It's called airports. So just to kind of give people a sneak peek, an intro to what this data set is, there's a person here named David Meganson who curated a data set of all of the airports in the world. So let me just look at this person's information. It looks like this person has a GitHub. A GitHub is a place where people kind of store code and data. So here, let me look this person up. GitHub. David Meganson GitHub. And then let me look up the air. What's it called? It's called the airports data. Okay, there it is. So this person curated something called a CSV file. A CSV file is just a large, you can think of this as a large text file that's comma separated values. So I'm going to click on it to see what it looks like. Okay, there we go. Okay, it's pretty big. It's 11 megabytes. It's kind of large for a bunch of text. So here, let me look at all this text real quick. Okay. Loading. Let's see. Okay, there it is. It's pretty, there's a bunch of lines in here. A bunch. Probably like hundreds of thousands or maybe tens of thousands. Basically, it contains data on all the airports. Here, let me zoom in a bit. So the first line in this file represents the column names. Right? And then the next lines are the actual data itself. Right? For example, there is a helicopter, there is an airport named Total RF Heliport. Right? That's associated with this column name here. There's another airport named Aero B Ranch Airport. Right? Another one called Lowell Field. Right? So think of this as a table. Right? It's like a raw table. Right? The first is all the column names, right? And then next are all the actual data inside those columns. Okay, so we could load this into a data frame. Right? Let's do that. We need to download this data though. So in the lab, the first line will download that person's data. Right? See this wget. This wget is short for web-get. It's saying download this CSV file. Right, so here I'm going to download it. And when you run this cell, you should see a new file here. Right, so here, let me run this. Okay, so I just ran it and it downloaded something. It should be in the same directory. Right? It's going to be in the labs directory because that's where our lab notebook is located. So let me navigate to the labs. Okay, there we go. So there we go, run it. Oh, it said I downloaded it 20 hours ago. I just downloaded it though. Okay, I just ran it again. It says 20 hours ago. That's weird. I should have said now. Let me refresh this real quick. Let me just refresh. Okay, I guess. Oh, I'm downloading too many of them. Anyways, Do folks see an airports.csv file in their directory? Okay, sweet. Yeah, so that file is here. Right? We just downloaded this large text file, and that's what the first line of code did. And you could look at it, right? You could kind of drag this and look at it split screen. You don't have to look at it, but here's kind of what it is. Let me pull it up. Yeah, see, that's our comma separated value, and here's the table representation. All of the names are here, and yep, it's a pretty large file. Let's take this file and load it into something called a data frame, right? Because this is just a representation of a file. Let's go ahead and represent this file in a data frame. So that's going to be this next part over here. Right? Question number 1 says load the airports.csv. Okay. So pandas, we need to import pandas, right? Because there is a function in that library that will organize that file for us. Right? There's a function, it's called read CSV. Right? In this case, I'm going to read the airports.csv. So this is a pandas function. So we have to, I forgot to say, we need a pandas dot read CSV. This is kind of doing two things for us. It's opening the file, and then it's loading it into a data frame. So this whole cell, the whole line will return a data frame. So I'm gonna store it in a variable called df. Right? You can call it whatever you want. Right? But once again, let me run this. Okay, hopefully that was successful. Sweet. So there we go. We just created a data frame, right, called df. Right? Once again, read CSV. There's a lot of magic happening here. it's opening that large file. Right? It's opening this large file right here, and then organizing all of the data into a data structure called a data frame. And so let's go ahead and visualize this. I'm going to take advantage of Jupyter Notebook's ability to show the result. So I'm going to do df here. Right? This way it'll show it. So I'll just df. And there we go. We have a representation of the airport data. Right. Pretty cool this so far. Okay. All right, let's see what the next one is. So yeah, once again, there are, how many rows here? Yeah, there's like a lot of rows here, like 83,000. And so yeah, it looks like there's like 83,000 airports in the world that are documented by this person. Let's do some filtering. Right, the second part wants us to use that data frame and filter the airports in the United States. So here, let me take a look through the data frame and look at the columns. Right, what column should we focus on? Let's see, let me go through all the columns. Right, it looks like there's a column called ISO country. So this is probably what we want to look at, right? We probably want to filter based off of this column. So let me select that ISO country here. So let's build up to it. So scrolling down, our data frame is called df, right? And there is a column called ISO country. Okay, so this is going to select a series from the data frame. Right, let's take a look at it first. Okay, there we go. All right, I selected a series, right? Once again, a series is a piece of a data frame, right? Here's a data frame, and then here's a series. Right, so we just selected a series of the ISO country, right? In this part, it's just like US, a bunch of things in the middle, and then also a bunch of other countries as well. Right? So, yeah. Oh, so, wait, am I gonna upload? Yeah, this is all recorded, so yeah. Yep. Do you have time to? All the lab deadlines are on the canvas, but you can still resubmit. Yeah. Yep. Peace out, tourists. All right, folks, on the recording. Yeah, someone was just asking about lab deadlines, but yeah, you can resubmit as many times as you want. Okay. Anyways, we are working on filtering the airports. So we just created a series of countries here. Right? We should create a criteria. Right? In this case, we need to represent a criteria that represents only the stuff in the United States. Right? So we can represent that criteria by saying, hey, where is this column equal to US? Right? So this is creating a criteria. So let me run this. It's going to give us another series, by the way, another series of booleans. Right, there you go. I just ran it. It gave us another series of where this is true. And so it looks like a bunch of the first ones were true, and then later on there's a bunch of false ones. Right, so we can use this criteria to select from the big data frame. Right, so here, let me select from the big data frame. Right, once again, selection uses the square brackets again. Right, so this is going to look tricky, right? df again, and then ending square bracket here. All right, once again, this is saying select from the data frame, but use this criteria. Okay, once again, folks might be wondering the syntax. It's a pandas syntax. Basically, the creator of this library made it so the criteria has this certain look to it. Anyways, I'm going to run this, and it should use this criteria and finally give us a filtered data set. Okay, so there's our filtered data set. Right, let's see how many things are in here. Right, so there are about 32,000. There's about 32,000 airports in the United States. Right, let me just do some sanity checking to make sure these are in the U.S. So let me just look at this visualization. Let me scroll over. ISO country, there it is. I'm just focusing on this one column. Yeah, it looks like they're all United States. In contrast to our earlier data set, right? The earlier data set up here, right? This had 83,000, right? And they're not all the United States. Right? See, ISO country, right? The first several were United States, but then these next ones aren't. Okay, cool. So here, let me comment this out real quick. So this is selecting from a data frame with a criteria. Right? And in this case, the criteria is a series of booleans. Right? So the series of booleans is right here. Right? Once again, if I take the step by step again, right, let me do this all over again. So we ended up making a series, right, and then creating a series of booleans, right, where this is equal to US. This is, so there it is. There's our series of booleans, and we use this as a criteria to select. So I'm going to use this whole thing and wrap it inside of the df. Okay, there we go. So yeah, we're selecting. Okay, hopefully people are cool with this so far. All right. Cool. Let's move on. Okay, let's do some more filtering. Right, this number 3 is saying, hey, filter and show only the row for the SJC. Right, SJC is the airport that's about 45 minutes away from us. If folks want to try it out on the recording, feel free. But yeah, we just need to filter out again. Right? I mean, we could use this U.S. airports, right? Like we could maybe store this into a variable and work on it, right? Like technically, this is another data frame, so I could store it in something called df of US filtered. Right? This is saying, hey, create this is saying select all of the U.S. airports, right? And then which returns a data frame, and then we're storing that data frame in a variable called df US filtered. And that's going to be our smaller. It's a smaller data set. So let me just take advantage of Jupyter Notebook showing the last run statement. All right, let me just run this again. Okay, cool. So let's work with this. All right, let's work with this new variable. In the next one, we want to filter based off of some attribute, right? In this case, we could filter off SJC. So here, let me take a look at the column names and see which column represents this airport code. So let me scroll up a bit. Okay, let me scroll through all of this. Scrolling. Okay. Let's see. It looks like it's in IATA code. Right, so you could find this out by kind of Googling it too, right? Like you could Google up something like airport codes. And so airport codes are typically, it says right here, right? IATA. I'm not sure what this stands for. Whoops. But yeah, whoops. Hold up, my thing is lagging. Okay, there we go. Yeah, so IATA. I'm not sure what that stands for, but it's probably the acronym for the codes we're caring about. Okay, so it looks like we could use this column name, and some of them are nans, right? Nans mean there's no value in here, so it's possible for many airports to not have these codes. I think it means that these airports aren't really meant to be booked, right? Meaning that you can't really purchase a flight to go here. Right? So in this case, this is a heliport, and there's no IATA code because it's not intended to be booked. Right, but looking down more, right? Let's look at more codes. So these are not a number. Right? These are not available, pretty much. Oh, okay. It looks like here's one, right? CZC. Let's see what this is associated with. So this is associated with Copper Center Airport. Right? So it has a code, meaning that I think you can book a flight to it. But yeah, anyways, we're focusing on filtering based off of this code. Right? So let's look for SJC. So we do have the filtered data frame. Right? Remember, it's called DF US filtered. Right? This is the data frame. Let's focus on that single column. Right? The column was called IATA code. Okay, so we're selecting a series from this data frame. Okay, there we go. So we're selecting, and there's our whole series. Right? It just grabs a single column. Okay. We need to create some sort of criteria that represents where this is equal to SJC. Right? SJC is the code, so we could create a criteria by using equals equals to SJC. All right. So this is going to give us a series of booleans. Here, let me run this. Okay, it gave us a series of booleans, which represents where this condition is true. Right? In this case, it's not true in most of them. Right? It's probably only true in one of them, which is somewhere in the middle. This ... So let's find out. Right? This is a selection. This is a criteria. We can use this criteria to select from the data frame. So let me select from the data frame, right, which we call df, right, and I'm going to use another set of square brackets. Okay, so let's run this. Okay, I just ran it, and yeah, so there is our filtered data frame. All right, well, once again, this is selecting. All right, this is selecting a data frame from a criteria. All right, in this case, the criteria is a series of booleans. All right, the series of booleans is in here, and then we're selecting from this data frame again. And it looks like there's only one row, right, which makes sense because there's only one airport that has the SJC area code. We're cool with this so far. Okay, just some quick little thing. This is not really showing the row, right? It is showing the row, but this is actually a whole data frame. Right? A data frame can have multiple rows, right? It just so happens that this data frame only has one row, right? Because our criteria only made one of them true. Right? It's possible to have a criteria that grabs larger data frames, right? So once again, this is not really a row, right? This whole thing is a data frame, and you can verify that with the type function. Right, so I'm just gonna use a type function here. Right, see, it is a data frame. It's not really a row. If you wanted to get the row, I mean, one way you can do it is by indexing the first thing, right? Indexing the first row, and there is a function called iloc, right, or an attribute, I mean, which stands for index location. Right? And in this case, I'm going to index the very first element there. Right? This is 0. Right? 0 is the very first element in this data set. So run it, and there we go. Right? We finally have a row. Right? This is technically a whole row. So, which is a series. So let me select. Let me make this comment a little better. Right? Selects the data frame, then also selects the first series in that data frame. In this case, the series is just a row. And that's what we're doing here, the iloc. Okay, folks may be wondering, oh, where am I getting this information from? I'm kind of hiding a lot of information from folks because pandas is a pretty deep rabbit hole. So iloc, this is a data frame function, right? Like, I mean, a data frame attribute. Right? This whole thing to the left of the period is a data frame. Right, so here, let me pull up some documentation. Right, you can look at pandas documentation for a data frame. I'm just going to Google it. Pandas documentation, and let me click on this primary source right here. Right, so this is going to show us all of the available functions to pandas. Right, in particular, we used something called iloc right down here. Right, and iloc stands for index location. Right, it basically allows us to select by integers, right, by its position. Okay, what else did we use? Let me see. Okay, yeah, there's a bunch of functions, so I'm kind of hiding away a lot of these from folks. Oh, we've seen these. Max, min, median. We've seen those. Okay. Let me go back to the lab here. All right. Cool, there we go. We technically grabbed the row. Right? And this row is a whole series. You can think of the series as like a fancy dictionary. A fancy dictionary meaning this is a key and this is a value here. So it's a bunch of key value pairs. Okay, and going to the next one. It says we need to grab a value from that SJC row. So in this case, we only want to show the URL to the website, right? And it looks like the URL is stored in this key value pair. This key value pair is called home link. So let's go ahead and access this. All right, well, once again, this does give us a series, right? It gives us a whole row, right? We might want to reuse this row to grab the data. So I'm going to store this whole row in something called a SJC row. Right, this way we can work with it and make things look a little cleaner. Right, this whole thing is an SJC row, so I'm going to run it. And here, let me just put SJC row here again, so Jupyter Notebook will show us what it looks like. Okay, there we go. So we have a variable that represents a row. Right, we need to use that and index this home link. Right, so we could do that by treating it like a fancy dictionary. Right, this is a series like a fancy dictionary. Right, and we could index based off of its a key. Right, in this case, it's just the home link. So we're grabbing it, and then there we go. That's the URL. Okay. Let's see. Cool. So we just did some filtering. Right? We just did some filtering algorithms, which really, we started off with this large data set. Right? This large data set was like 83,000 airports. Right? We ended up creating another data frame. Right? And this data frame is the US, right? The United States. And this new data frame turned out to be 32,000 rows. Right? And then next we filtered it again to a single row. We took it and then filtered it again and grabbed a single series. Right? And then finally we reduced it down to this website. Okay. We're going to move on to some reduction algorithms. All right, once again, all we did was filtering. Let's move on to reduction, which, once again, from last week, reduction means we're going to be taking a whole series, I'm taking a whole sequence, and then collapsing it down to one value. Okay, let me go to the lab. Okay, so we want to find the lowest elevation of any airport. Right? That's what this next part of the lab is. So we're not going to be working with the filtered data frame anymore. Right? We should be working with our original data frame. Right? That was called DF, I believe. Let me scroll up. Right? Our original large data frame was called DF. Right? So we're not going to work with this filtered one, right? Because we want to find the lowest elevation of any airport, right? Any airport. So let's work with the original one. Right? Once again, it's called DF. And that's our original large data set. Okay, let me just verify. Yeah, there's 83,000 things here. Cool, this is our original data set. Okay, we want to find the lowest elevation of any airport. So let's see what column we should select from before we do any math. Okay, let me scroll over a bit. Okay, cool. It looks like there is a column named elevation in feet. All right, so let's select this column. Once again, we can select with these square brackets. I'm going to select the elevation of feet right here. This is going to return a series. And we're selecting from a data frame. It gives us this series right here. And in this case, the series represents the latitude and longitude. It looks like for the first airport, it's like 11 feet above sea level. Next one is 3,400 above sea level, and so on. And it looks like there's some missing values here, not a number, right? Nan means that the data has nothing in here. So whoever, the person who created this data set probably couldn't find out the number, right? The elevation of this airport right here. So yeah, it's just missing data. But basically, when you download large data sets, it's possible for values to be missing. Okay, anyways, we want to do some reducing algorithms, right? Find the lowest elevation of any airport. So the cool thing about this right here, this is a series, right? Series have a function called min, right? It's got a function called a min right here, right? And that's going to give us a single number. Right? This is pretty much saying, hey, get the series and tell me what the smallest number is. Right? And it just so happens that negative 1200 something is probably somewhere in between. Right, so let me do this min again. Okay, and if folks are wondering how I knew about this function, right? Once again, this is a series, right? So I could look at this type. Right? This is a series, and it has a min function, right? So let me look at the series documentation so I can show it, right? So pandas series, Google it. Okay, so here's the pandas series. When we click on documentation, this is going to show us a lot of available functions we can use with these series. In this case, we use something called min. So let me, right here, right, we use a function called min. So let me just click on this. And yeah, here's some documentation. Right, there's some examples on kind of how to use it down here. Well, yeah, that's what we're doing, right? We're the series to the left of the period, and then the min, right? Gives us the minimum of all the values. Okay, cool. So this is the this is a number, right? This is representing the airports with the lowest elevation. It's not really giving us the name though. Right? It might be necessary to print the airport that is associated with this elevation. Right? So how do we use this number to get the name? Right? Well, I mean, we could use this as a criteria, right? Like the criteria. Well, this is technically representing the lowest elevation, right? So I'm going to store it in a variable. This variable is going to be a float. Right? We could use this lowest elevation. So here, let me this here lowest elevation. And we can use this as a criteria. Right? So let me create another cell here. We need to make a criteria that filters based off of their elevation. Right? So here, let me select a series. Right? Basically, this is the series, and we need to create a criteria. So I'm going to say, hey, where is the elevation equal to negative lowest elevation? Right, so this is going to give us another series of booleans. So let me run it. Whoops, kind of scroll down a bit, my bad. Okay, so I just ran it, and it gave us another series of where this criteria is true. Right? If anything, most of them are false. Right? So let's see where this is true. Let's use this criteria to select from the original data frame. So I'm going to wrap this in the data frame. Right? So df square bracket and another one at the end. Right? So this is saying, hey, select from the data frame using this criteria. Right? Where is everything? Right? Well, where is the elevation equal to this lowest one? So let me run this. Okay, cool. So I just ran it. Right? It looks like we have a data frame of one row. Right? It just so happens that there's only one airport that has this elevation. Right? It's possible for some other airports to have the same elevation. So but basically I'm saying that this is a whole data frame with one row, right? It's possible for a data frame to have multiple rows. Like if I were to if I were to put like a less than here, right? Like if I were to say, hey, the criteria is where is the elevation less than the low's elevation, right? As a sanity check, there should be nothing, right? Nothing is lower than the low's elevation. So there's nothing in this data frame. And let me verify with the greater than, right? With the greater than, right? This is saying where are the airports that have more than this low's elevation, right? It should be every single airport except one, right? So let's verify. So it looks like there are this many with one. Oh wait, hold up. 68,000 EF. 68,000. Let me verify this real quick. Yeah, let me look at the original EF. Okay, that's weird. Huh. Okay, I'm just doing some sanity checks, verifying the numbers. It should have been like 80,000 something. Oh, you know what? It's because there's a bunch of nans. So you might be wondering why this number isn't like one off from the original data set, right? Like basically the original data set is like 80, 82 something. So I was expecting this data frame to have one less row, right? But that's not the case. That's not the case because there's a bunch of missing data in this file. Right? But basically, there are some nans, right? Like this elevation feet right here. The data set has some missing data, so you might see some nans in between. You don't see it here, but in between these dots are a bunch of not numbers. Right? Basically, the person who curated the data set couldn't get all of the information. Okay, anyways, we were back to filtering. Right? Our original let's see, goal was to find the lowest elevation of any airport. Right? So we stored the lowest elevation, and we're going to use that as a criteria. Right? And this criteria gives us one row. Right? There's only one column, one row, I mean, that has this elevation. Right? It's this airport right here. It looks like it's negative 1,200 underneath sea level. Once again, we want to maybe print out the name, right? So how do we access this name here? Right, well, this is technically a row, right? Or I mean, it's a data frame, right? This whole thing is a data frame. So we'd have to grab this very first row. Right? And one way we can do it is just by saying, hey, grab the index location at 0. Right, once again, this left side of the period, this is a data frame. So the data frame dot iloc will give us the row at the position 0. So this is going to give us a series right here, right? A row is like a series. Okay, so there it is. This is the row with the lowest elevation. Right? If anything, we need to access the name now. So this is a series, which is like a fancy dictionary, right? And we need to access this key value pair. So we can access that key value pair by saying name here. Okay, so yeah, that should grab as the name, right? Once again, this left side is a series, and then we're indexing the key name, right, which will give us this over here. So let me run this. There it is. Bar Yehuda. Okay, cool. All right, let's see. Use the expression in the last question. This is the next one. We want to show all the data on the lowest airport. Oh, we actually already did that. We just had to trim some stuff from here. But here, let me work up to it again, right? Like we wanted to grab the data on the Lowe's airport, right? So we are selecting based off the elevation feet, right? So this is a whole series. We want to make the criteria, right? The criteria is where is the Lowe's airport, right? In this case, the criteria is the value is equal to lowest elevation. All right, so there's our criteria, and we can use that criteria to index the data frame, right? So I'm going to index the data frame here. I mean, select from it. Right, so select from the data frame using this criteria, and there it is, right? This is showing all the data on the Lowe's airport. Right? Technically, there can be multiple rows. Right? There could be a lot of the same airports with, I mean, there could be a lot of airports with the same elevation. So I'm going to index the 0th row here, just to be safe. Right? And there we go, right? We're technically showing all of the data on the Lowe's airport now. All right, let's go down. Okay, let's see. I'll let folks do number 7 by yourself. Calculate the median elevation of all airports. Basically, it's the same thing as this mean right here, right? But instead you're going to want to use a median. Right? Like you can pretty much use this series and then say dot median. So I'm pretty much pointing to this right here. Let's see, median. Right, yeah, it's the same thing, but instead of a min, just use a median. Okay, let's go down a bit. Okay, so yeah, try that out. And then finally, for the histogram, Pandas has some graphing abilities. Right, we'll see this in just a bit. What if we were to print a histogram? Right. Once again, a histogram is a way of representing frequency. Right. Like how many airports have this elevation, or how many airports have this elevation. Right. So let's go ahead and visualize that. So we are focused on the elevation in feet. Right. So this is a series. Right? We can use this series to plot a histogram. All right, a histogram will tell us, it'll kind of bend things together, right? So here, it'll make sense once I plot it. So there is an attribute called plot, which has a function called a histogram. Right, we'll talk about this later, right? In the lesson. This is just a sneak peek. And so this is going to give us a histogram, which is kind of representing like the frequency of the airport elevations. Right? It looks like most airports are between these numbers, right? So you see how the biggest bar is here, right? So this is saying there's like about 30,000 airports that are within this elevation. Right? The elevation goes from like negative something to 2,500, right? And then going on into this bar graph, right? There's less, right? There's less airports at the elevation 7,500. Right, so once again, this is just a histogram, a fancy way of saying a frequency graph. Okay. All right, so we're pretty much done with the lab. If anything, folks will need to do the median elevation. Okay, I understand that this is really dense. We covered a lot, and we didn't even look at the lesson yet. So let's jump into the lesson in just a bit. All right, let's kind of summarize what we did so far. We started off with a sneak peek on a small data set. Right, in the very beginning of lecture, we did a small data set that just represented names and ages. Right, so, and then we moved on to larger data sets. Right, the airport data. Right, this is the airport data right over here. Right, we downloaded someone's data and then used it to kind of learn some things from it. Okay, I hope people are getting a sense of what Pandas allows us to do. Pandas is a library that allows us to kind of do looping algorithms a lot faster. Right? Like in the previous lesson, in the previous week, we had to write manual for loops. Right? We had to write for loops that goes through a data structure and then do some if statements. But Pandas does it for us. Right? It does the filtering for us, so it already does the for loops inside of the functions. Okay, here let's jump into the lesson. So we just finished the lab. All right, so jumping into the lesson right here. All right, so I understand this is really dense. Uh, it takes a it took me probably like a year to get comfortable with pandas. In my university days, I would use pandas a lot for doing projects. And pretty much, I was in the machine learning laboratory where we analyze large data and make prediction from it. Right? I ended up using pandas a lot, and there are some classes that teach pandas in a whole semester. Right? So there's a lot. If anything, we're covering pandas in like a single day, so we're not really going to cover everything. But I do want to reiterate that this library is pretty deep. Right? We're only going to see a couple little things. Right? We're really only going to see filtering algorithms, right? And mapping. Right? We're going to see these. Filtering again, and then reduction. Right? That's all we're really going to see. There's so many things you can do. Right? But I do want to reiterate. Let's see. I do want to reiterate that this library is very large. There's classes that teach how to use these. If folks are interested in how to use pandas, if you take a data analysis class, they will probably teach this. But we're only gonna do a couple things. All right. Cool. Yeah. So once again, I do have a lot of projects in pandas. Right. Before we jump into here, right, I just want to give a high-level overview on uh, on some stuff that you might end up doing. So let's see. I store a lot of my projects on a personal website. Right. So basically, in my university days, I did some machine learning projects. Right. One of them was taking email data. Right. So imagine that I downloaded a bunch of emails and then analyzed it to predict relationships. Right. Like you could predict who's a CEO, right, by looking at all the messages. Right. You can predict who's a manager, who's a programmer. Right. Pretty much take a large data set, load it into a data frame, and kind of learn from the columns. Right. And I also did a project on drug interactions. But basically, you can think of a data set of drug molecules, and you can kind of do some protein analysis, or not protein analysis. It's like a nucleotide stuff, like DNA stuff. Right? You can pretty much take a bunch of those. And I do have source code available on here too. Right? Like here, let me go back to the email stuff. Right? So let me go to the email. I have some source code here. And yeah, you see, I use pandas a bunch, and a bunch of stuff with, let's see, a bunch of stuff with data frames. Right? See that this is emails. Right? This is emails from a company called Enron. Right? So I'm pretty much taking a data set from a company and kind of learning from its data here. That's some pretty cool stuff. Right? Pandas lets you do a lot of things. Okay, so here let me go back to the lesson. This lesson is going to give us some really good hints for the next project. The next project is the same as the previous one. So here, let me just pull up the Cabrillo canvas real quick. Let's see. CIS 15. All right. Spit something out. Okay. So once again, we're on week 13. Right? The next project is Major League Baseball players, but with pandas. Right? So if you did the previous project, which was pretty much writing loop algorithms to go through data structure, right, we're going to do the same exact thing. But we're going to use pandas. Right? Pandas, once again, stands for panel data. We're going to use this library to clean up the code previously. Right? It's going to be possible to kind of do your previous assignment in like maybe a few lines. It's totally possible. Pretty much the previous assignment was writing for loops with if statements and a bunch of math, right? But pandas would do all of that for us. So that's what the lesson is going to give us a hint towards. This lesson will work with a data set called Major League Baseball players. So let's go ahead and load it up. Okay, cool. So in this lesson, the very first cell is loading up a file, Major League Baseball players. It's loading it into a data frame. If folks don't mind deleting this second argument, right, this second argument in the read CSV, it's not really that necessary. It's kind of changing the shape of our data frame. Right, I'm going to leave the shape as a plain one for now. Right, so go ahead and delete this. Right, you don't have to, but I'm going to delete it just to keep things a little simpler. Oh, I can't delete it. If you can't delete it, you might have to change the permissions on this cell. So just click on this cell, go on the settings here on the top right, and then change it to editable. There we go, it's made editable. So once again, just go ahead and remove this second argument. Right? It'll keep the shape of the data frame more plain. Okay, cool. All right, cool. So we just loaded a Major League Baseball players. Right? Once again, if you did the previous assignment, then you're already familiar with this data set. So we loaded it up and stored it in a variable called df. Right, let's work with this df. Right? Let's work with this data frame. Okay. So as we see, this data frame has several attributes. Right? It's got the name, team, position, and some height and weight. Okay, let's go down. Right? Okay, let's go ahead and select a series from it. Right? So a data frame is like a bunch of series put together. Right? Let's go ahead and filter and select one single series. Now, for example, the height. Right? So here's the df, right? The data frame. Right? Once again, when we select, it's with the square brackets. Right? This is going to select the height attribute. There we go. So there's all the attributes. Okay. And we can do other stuff too, right? Like, let's see, is there age in here? Let me look at the data frame. See their age. Oh, they do have the age here. So yeah, you can look at the age too, right? Like df and then age. Right, this is giving us another series. So once again, let me comment this. This is selecting a series from a data frame. That's what it's doing. Okay. Cool. Okay. I'm kind of jumping ahead, but you remember how we can filter based off of criteria, right? Like, what if we were to see who is above 35? Right, so let me see who's above 35. Right, basically, I'm going to create a condition. Right, this is saying compare every value in age to 35. It's going to give us another series of booleans. So this series of booleans tells us where people are greater than 35. Right, once again, we can use this criteria to select from the data frame. Right? And remember, when we select, it's with the square brackets. Right? So we're selecting from the data frame. There's another set of square brackets. Right? And then run this. And here are all the players that are above 35. See, it looks like there's 100 players above 35. So this is kind of doing two things. It's selecting based off of this criteria. Okay, it is some weird syntax though. Hope folks kind of get used to it a bit. Okay, cool. Let's do some mapping. All right, once again, we can think of mapping as taking a column and converting it to another one. In this case, we're going to create another copy of the column because it might be safer to not touch the original column. Right, like it might be safer to add a new column because we don't want to touch this original one. Otherwise, you're modifying original data and you can lose information. In this case, we're going to use a mapping algorithm to add information. All right. In the previous assignment, we had to convert some metric systems. Right, like here, let me pull up the previous assignment and kind of the previous assignment. Where is it at? Major League Baseball players. Okay, in the previous assignment, one of the tasks was to calculate the BMI. Right? And the BMI kind of relies on this metric system. The data set stores it in inches and pounds, meaning that the formula is a little different. Right? Basically, they're converting the pounds to kilograms. Right? To convert it to kilograms, you're multiplying it by 0.454. Right? And then when we're converting the inches to meters, you just multiply it by this number here. Well, it is possible to add information to the data frame. So let me go back to here. Right? Like imagine that this yellow column, represents their pounds. Right? And what if we wanted to map it into another column that does it in kilograms? Right? That's totally possible. We can add on to it. Right? And basically, we can do that by doing a mathematical operation, divide by 2.205. Right? Once again, this is the same. If I were to look at the previous project, right, this is the same as multiplying by 0.454. Right? Multiplying is the same as dividing, pretty much. So, yeah, basically, this is doing the same exact thing. Right? It's the same exact thing as multiplying by 0.454. Okay, so let's see. Right, so we do have the weight, right? Like df weight. Okay, so we do have the weight right here. Once again, we're selecting a series. We can perform math on all of these numbers. Right? You just take this series, right, divide it by 2.205. Right, once again, this is going to give us another series. Right, so here, let me try it out. There it is. See, it gave us another series. It took every single number in the original weight and divided it by this number. Right, once again, this is the same exact thing as multiplying by 0.454. Right, so multiplying by 0.454, right, same thing. Right, see, same numbers. It's just multiplying by the reciprocal. Okay, I'm gonna keep it like this though. We can use these numbers, right? So we didn't really modify the data frame yet, by the way. Right, this is just an expression. Right, this expression didn't modify the data frame. It's just kind of calculating another series. Right, let's go ahead and use this brand new series. Right, see, this is representing, by the way, this is representing, it's converting pounds to kilograms. Right, that's what it's doing. So it's converting, right? We need to use this series and kind of add on to original data frame. All right, once again, our goal is to add this pink column, right? And this is not really adding on to it. It's just doing some math. Right? So one way we can add on to it is by assigning it. Right? It's just like dictionaries. Right? Like imagine we're in a dictionary. Right? Let's say we were to index the weight. Right? But imagine if there was a column name called kilograms. Right? This is going to give us a key error. Right? It's saying it doesn't exist yet. See, key error, weight, kilograms. Right? It makes sense. It makes sense. This doesn't exist yet, right? Because if we look at the data frame, here, let me just delete this. Right? If we look at the data frame, there's no column named weight in kilograms. So I hope that makes sense why this gave us a key error. We can create this column. Right? Basically, we can insert a value by saying, hey, set this equal to something. Right? This is telling the Python interpreter that we're going to create a brand new column. Right? And then whatever that brand new column will be equal to this right side. Right? In this case, the right side is just going to be this series. Right? So here's a series calculation. We just have to reuse that in here. Right? So once again, the right side gets evaluated, gives us a series, right? A series of kilograms, and then we're going to store it in this brand new column. Okay, so I just ran it. It didn't output anything because all we did was assign. Right? But if we look at the data frame, right, I'm going to take advantage of the Jupyter Notebook showing its last run cell. Right, there it is. I'm just looking at DF, and yeah, you see, we added a new column. Pretty sick, right? And we added a new column, right? We pretty much mapped this old column and then added on some information. Right? That's what happened here. So let me just comment this. This is mapping this maps pounds. No, it maps the US metric. I don't know what the US metric is called to metric. Yeah, I forgot what the US metric is called. I'll just say maps US system to the metric system. Right, once again, the visual here is this right here. Right, we took the pounds and then mapped it to another series, right, and then we added that series to a brand new column. Right, that's what's happening down here. There's two things. Right, create a series and set it to this brand new one. Okay, so okay, let me just comment this again so folks are aware. Right, so the right side of the equal sign, right side of the equal sign, this calculates a brand new series. It calculates a series in kilograms, right? And then the left side is equal sign. It creates a brand new column, right? So there's two things happening here, right? The right side is doing math, and then the left side is creating a new column, right? So the right side gets set to the left. Okay, we need to do the same with the height, right? Because when we're calculating BMI, it's easier to work with the metric system. So let me do the same with the height. Right, once again, the conversion, right, is over here. We see on the previous one. On the previous assignment, right, when we convert inches to meters, right, you can just multiply it by this number, right, 0.0254. And once again, this is the same as dividing by its reciprocal. So we can just divide by its reciprocal right here, right, 39.37. So here, let me take that. Let me work on the right side of it first, because that's kind of the control flow here. Oh, hold up, I did a shortcut on accident. Okay, so let me take the height. So height. All right, so we need to convert the height to what's it called? The kilograms. I mean meters. So basically, we take these inches, right, and then divide it by some number, right, 39.37. Right, so this is, once again, this is the same as multiplying. It's the same as multiplying by 0.254, 0.0254. Right, so this right side is calculating another series in metrics. Right? So now we need to take that series and assign it to a brand new column. Right? So on the left side, I'm just going to create a new column. Right? This is saying df, and I'm just going to call it a height in kilograms. Right? Here we're creating a brand new column called height in kilograms. Okay, so check this out. I'm going to run it, right? And when I run it, you should see a brand new column here. Right, so let's see. I'm going to run it. Boom. Yeah, I just ran it. See this brand new column, right? Height in kilograms. Right. Okay, cool. So all we did was mapped two different numbers. Right? We mapped the weight and the height and added two new columns. Okay. Okay, cool. Let's go ahead and go on. So once again, the reason why we did this is because in the next assignment, you're going to have to calculate the BMI. Right? And the BMI is easier to calculate when we use these two columns. Right? Like all we have to do is divide them. Right? Like if we were to calculate the BMI, right, the original equation was just divide the kilograms by its meters squared. And so let's go ahead and create that BMI column, because we don't have it. Right? Check this out. See, if I type in df and select the BMI column, right, it says it doesn't exist. A key error. So let's go ahead and make it exist. So we're mapping again, right? We're creating another column called BMI. Right? In this case, we can just relate the two together. Right? All we have to do is take the weight in kilograms, right, and divide it by the height. Right? So I'm going to go ahead and do right here, right? Divided by df. And then this denominator is squared. So I'm going to go ahead and square it. Okay, there we go. Cool. Okay, let me just fill in this numerator. Right. Once again, the numerator is the weight in kilograms, and we do have a brand new column, right, called weight in kilograms. Right, and then the denominator is the height in meters. Right, there we go. So run it, and it's going to create a brand new. Oh, I got a key error. So let's see what happened here. Oh, you know what? Okay. So key error here is saying a height in meters doesn't exist. Basically, I made a mistake when I created the height. Earlier, you see our new data frame? We don't have a height in meters. Right? The height, that this key is height in kilograms, which doesn't make sense. So let me go ahead and recreate this. Right? So the height in meters, right, there we go. Just change that kilograms to meters. And now let me rerun it. Okay, there we go. Cool. Okay, sweet. So now we have that new key. Hopefully it works now. It looks like this old key was here. I mean, you can remove this. It might be easier just to start from the top, reload your data frame. Right, so if you want to get rid of this, you can just start from the very top and run it over again. Right, basically, you're just going to hopefully end up with this height. Okay, so let me rerun this here. Okay, hopefully there's no key error here anymore. Right, this should exist. So let me run it. Okay, cool. No errors. Right, it didn't output anything because we're assigning. Right, but let me look at the df. Right, this is, once again, Jupyter Notebook shows the result of the last run. So I'm just going to put the df there. Okay, sweet. So there we go. We have a BMI, a brand new column. Right, so let me just comment this. Right, this is creating a BMI column. Right, it's like another mapping algorithm. Right, this is technically it maps two columns to one column. Right? It's mapping this weight in kilograms and the height in meters, right? And it's mapping it to a brand new column called BMI. All right. Cool. All right. So yeah, with this BMI column, right, it's going to be a lot easier to do your assignment. I remember the Major League Baseball players assignment, right? You just had to find the minimum and the maximum. So those are reduction algorithms, right? You're basically going to look at a single column, right, a single series, and do the min, max, and mean. Right, so let's talk about reduction algorithms now. Let's see. I'm going to skip over this part right here. Folks can look at this later. It's pretty much another way of mapping. Okay, let's do some filtering before we reduce it down to the min and max. All right, so we do have the height. Right, let's work with the US system. Right, this is just a plain height in inches. Right, so we've seen filtering algorithms before, right? Like DF. If we select the height here, right, yeah, height. Actually, I'm just going to use the age. Let me use age here, just because people are probably bored of height. All right, so once again, we're selecting a series, right? A series from a data frame, right? And we can use this to filter. Right? We need to create a criteria. So let's just say I was, we already did this, right? Let's say the criteria was, you're greater than 40. Right, let's see who's greater than 40. Right, so it looks like most are false. Right, once again, this is creating another series. This is a series of booleans that represent where this is true. Right, we can use this as a selection criteria. So let me select from the data frame with this other set of square brackets. Okay, there we go. Bless you. Selecting. Okay, let's see who's older than 40. Okay, cool. It looks like there's people here. Yeah, it looks like this many people are above 40. Cool. Let me just go above 45. Above 45. Okay, cool. There's only one person. The person is 48 years old. Okay, yeah, so this is just filtering, right? We basically created a series of booleans in here, right? And then selected it, right? So here's our, I'm gonna take a step back again. Right, this is our series of booleans, right? Most of them are false. There's only one true here. We're using that series to select from the data frame. Right, so there we go, and then one person. Okay, cool. All right, let's do some reduction, and then we'll be done. Let's see. Okay, the assignment will ask us to calculate some min and max, right? Like, who's the smallest person? Who's the biggest person? And maybe the average as well. Right? So the previous assignment, I just pulled up the previous project. Right? We're going to have to use the BMI to do the average, min, and max. Right, so let's do those reduction algorithms. Okay, so there are a bunch of functions attached to series. Right? These are series functions. Right? But basically, I pulled these up in the documentation already. You can just look up something called Pandas series. Right, and then go here. There are so many series functions. Right, we're only going to see a couple of them. We're going to see the min. We're going to see this min right here. We're going to see the mean, and then the max. Right, that's all we're going to see. So let's do that. That's what this is kind of saying, right? This is a series. Right, we can do the sum, we can do the median, and all the other stuff. Okay. Let's say we were to, calculate the. Let's see that. Let's do the average. All right, so this one doesn't really show the average, but if you look at the documentation, there's one called the mean. right? The mean is a synonym for average. So let me go ahead and do that, right? Let's do the df, and then let's do the height. Let's do the tallest person. df.height.average. I mean, not tallest person, my bad. Mean. This is the average of the heights. Right, we're just taking a series and saying dot mean. Right, but let's go ahead and see if we can print out the tallest person. Now, once again, this is very similar to your homework. Right, the homework will actually ask for the biggest person. Biggest person is defined by the BMI, but here we're just going to use the tallest. So df height. Right, let's see what the tallest person is. Right, so max. Right, this is going to reduce this whole series to a single number. Right, in this case, it's 83. Okay, this is saying that 83 inches is the tallest person. Right, but what if we were to print out the person who had that height? Right, like what if we were to print out the name instead of the number? Right, because maybe it's useful to see who's associated with this number. Right, well, we could probably use this number as a selection criteria. Right, like let me store this. This is a number. Right, let me go tallest height. Right, this is a number. So let me store it and then just visualize it here. I'm going to print it instead, actually. Verify. Okay, there we go. We could use this number as a selection criteria. Right? So let's say we were going to select from the height. Right? So I'm just going to select the column and see where it is equal to the tallest height. Right? So this is going to give us a series of booleans. Right? So it's going to tell us where this is true. Okay, it looks like most of them are false. Right? There should be a true in the middle though. So let me use this criteria to select from the data frame. So I'll select from the data frame. There we go. It looks like there's only one person that has 83 as a height. Right? It is possible for this to print out multiple things. Right? If multiple people had the same height, right, this would print it out. Right? So yeah, it is possible. This is a data frame, right? Meaning that we should grab this first row. Right? So one way we can grab the first row is by using the iLock, right? For index location. We can use index location, grab the first row, right? Grab the first series in this data frame. Okay, there we go. You just grab the first thing in that series, right? The series, you can think of it as a fancy dictionary. So if we wanted to get the name, right, we would just have to index this name key. So this is going to look tricky, right? I'm just going to put here some curly braces, square brackets, and then name. Right? Because everything to the left of here, this is just like a fancy dictionary. So we're saying dictionary, grab the value at this name. Okay, so there we go. It's printing out John Rauch. That looks about right. The tallest person. And this is a string, so it might be useful to print out, to store it, right? Like tallest person's name. Right? This is technically a string, so we could print the tallest person, or not print, right? We're storing the tallest person, and then now we can print out the name that's associated with it, right? Like we could print out tallest MLB player is. Let me just use a string actually. Right, there we go. Right, tallest person is John Rauch. Right, and I guess we could want more info with the height of tallest height. Right, tallest height is a number that we used for the criteria. Right, tallest MLB player is John Rauch, height of 83. Okay, cool. So hopefully that helps people with the next assignment, because it's just going to ask to do the smallest and largest players. Right, but don't use the height. You're going to want to use the BMI, right? Because we're using BMI to make the criteria. Okay, let's see. Okay, we're almost done. Let's do one more thing, and we'll be done. So finally, plotting, right? A Pandas library has so many different types of plots we can use. Right? We've seen histograms, right? A histogram is like a frequency counter, right? And it's got scatter plots too, and some other types of charts. Right? Let's do a histogram because these are probably the easiest to represent. Basically, histogram just counts things and tells who's within that range. Right? Like if we wanted to make a histogram of the BMIs, right? Let me look at the BMIs real quick. Let me make a new cell here. Right? DF BMI. Right? So there's our BMI. This is a series. Right? You can look at the documentation. A series have a attribute called plot, right? And it's got another function called a histogram. Right? You don't have to look at the documentation here. Right? You can do a dot plot. Right? See, it's got a dot plot, and then the dot plot has a dot histogram somewhere. Right? So you can look at this right here. This is what we're going to use, right? Dot plot, dot histogram. So let's go ahead and use that. Right? And then it's going to give us a distribution. Right? This is the distribution of heights. I mean, BMIs. Right? Basically, most people have an average BMI of 26. Right? You can verify this later by calculating the mean. So, I mean, you can sanity check this. So here, let me sanity check to make sure. Right, let me go DF BMI. Right, let's maybe reduce this down to the mean. So mean is 26. Right, the average BMI is 26. And yeah, our histogram looks like it's verifying it. Right, 26. There we go. Okay, so yeah, that's about it for today. Just to kind of give a conclusion, we're a bit over time, so thank you all for staying a bit. We did 3 things today. Right? We did the lab together, right? Lab 18, and then we did the lesson as well. Don't worry about the rest of the lesson. It's going over some more fancy stuff, right? Like complex filters. You can take a look at this if you want. It's only if you're more curious about doing more on data science. So you don't have to do the rest of this notebook. If anything, we should be good from here, right? All the way up to this plot. Okay, so we did the lesson 18 as well. And lesson 18 is the biggest hint for this next project. Right? Once again, this next project is the same as the previous. The only difference is we're going to be using the Pandas library to clean up code. Right? Our previous code, we ended up doing a bunch of for loops, if statements, a bunch of multiplication. I mean, math. Right? But this new one, this new with Pandas, it will allow us to clean up the code. It's going to be so much cleaner. Right? You can probably do this next assignment in like several lines, like maybe less than 7 lines. You could probably get it done. Okay. Thank you all for coming, and have a great day, folks. Great Monday.